Okay, here's my video reassessment for vectors. So the question I chose was a plane leaves the airport on a bearing of 45 degrees traveling at 400 miles per hour. The wind is blowing at a bearing of 135 degrees at a speed of 40 miles per hour. What is the actual velocity of the plane? So if you draw the first part, here's the plane if it's leaving the airport, traveling at 400 miles per hour, bearing of 45 degrees. And then the second one would be the wind blowing at 40 miles per hour at a degree of 135. So if you put those two together, you would have the plane leaving at the 45 degree angle with the wind vector right here. So it's gonna push the plane a certain amount this way, and this would be the total of where the plane is going. So if you have the total equals the plane vector plus the wind vector. So if you find the x component of the plane, you're gonna take 400, the cosine of 45 degree equals x over 400. So if you solve that for x, it will give you 400 cosine of 45, and x is going to equal 283. And the y component would be sine of 45 equals y over 400. So 400 sine of 45 equals y, and then y equals 283. So the vector for the plane would be 283, 283. And if you find the wind vector, the x component is going to be the cosine 45 equals x over 40, which is going to give you 28.3, and the y component is going to be the sine of 45 equals y over 40. If you solve for y, it's going to give you y equals 28.3, so then the wind vector would be 28.3 comma the negative 28.3 because it's going south. It's in the negative. So if you add those two together to get the total, here we have the 283 plus the 28.3, then 283 plus negative 28.3, it's going to equal 311.3, and then 254.7. So from there you have to find the velocity of the plane. So this is going to equal this vector right here. And if you find the velocity, you take the magnitude of the vector t. So that's going to be the square root of 311.3 squared plus the 254.7 squared, which is going to give you 402 miles per hour for the velocity of the plane.